In this tutorial, we will learn how to set up an equation-based analysis. By following these steps, you will ensure that you have all the information you need to successfully create prescriptions and various management layers. To begin, select Analysis Wizard in the main toolbar. In this window, click Equation-Based Analysis on the left. To create a new equation, click Add. In the Name Description window, enter a unique name and optional description for this equation. This name will be saved to the Equation-Based Analysis Functions list. Click Next. On the Defined Analysis Results window, we will define what we want as the resulting layer after we run the analysis. So, if we are creating a fertilizing prescription for lime, we would first assign the result operation as fertilizing prescription dry and the result product as lime. We need to assign the attribute that will be created by selecting Add, entering a result name, then selecting an attribute. Since this is a prescription that we want to apply a rate as mass, we will select Target Rate Mass, then select the units we will be writing the equation in. In the result settings, you have additional options to refine the results further. First, you can apply minimum and maximum limits. Minimum value is the lowest allowed value generated in the prescription. Minimum non-zero value is the lowest value to be applied if it is greater than 0. For example, if the lowest reliable spread rate is 60 pounds per acre for your applicator, set this value as 60. 60 pounds per acre will be applied if any rate is over 0 pounds per acre, but those areas that need nothing applied will still be set to 0. Maximum value is the highest rate that will be generated from the equation. Next is round value to. By setting a value for your results to round to, you can reduce the number of unique values that are created by an equation, which is practical for variable rate prescriptions when applying in the field. So, while SMS will calculate application rates down to quarter-pound increments, application equipment can't vary by such small amounts. So setting it to 10, 30, or 50 pounds will lead to faster generation of results and a more accurate picture of what will actually be applied in the field. Lastly, we have minimum area. This option will merge small areas generated in the results, reducing the number of areas that are created and not practical because of their size. If you opt to apply a minimum area, you will have two additional options to select: Auto and Fixed. Auto will apply a minimum size that will change based on the field size. With Fixed, you can set the area size you desire no matter the field. After you have the desired attribute and result settings selected, click OK. If you would like to create multiple results for different products, you can add additional analysis results. Add more by either clicking on Add Analysis Result or Copy Analysis Result to duplicate the previous one. This can benefit you by running several different equations for different products at the same time. After you have the analysis result defined, click Next. On the Analysis Input Datasets window, you will select the data you would like to reference in the equation. In this case, we will be referencing soil sampling data. Click Add Dataset and use the data filter to select the data you want to reference. Select Next, and this is where you can delete items you don't need referenced. Then select Finish. On the Input Dataset Settings window, you can edit the name displayed, what data is currently selected, and change interpolation settings if needed. Select OK. Add any additional datasets you would like to reference, then click Next. The Select Management Item Inputs window is optional, but is used to pull information from product defaults, such as using a recommended product rate value. Click Next. The Define Result Equation window contains all the settings for creating an equation. Let's outline the different areas and their uses. First, we have a list of the analysis results and attributes that we created on the Define Analysis Results screen. Each of these results will require us to set an equation for them by selecting each one and entering the equation we would like to use for that result. Select the result that you would like to start writing the equation for. This is the area we will use to view and build the formula for each of these results. Next, we are going to select the attributes from the data sets we previously selected to reference in the equation by going to the Variable and Spatial Functions and clicking Edit List. On the Add Edit Equation Variables and Spatial Functions window, we will use the filters to choose the attributes that will be referenced in the equation and click Add to select them. After you have the attributes you want to reference, select OK. Now, we move to the Equation Functions area, which contains all the math and logic operators you can add to your formula. There are also two time-saving tools we want to introduce, the Range and Logic Wizards. The Range Wizard helps you build an equation using custom ranges you defined, and then easily enter the rate you want to apply to that range. As an example, if we were creating a prescription referencing soil pH, we could assign areas that have soil pH values of 0 to 5 to apply a rate of 1,000 pounds per acre, pH of 5 and 6, a rate of 800 pounds per acre, and 6 to 9, a rate of 500 pounds per acre. The Logic Wizard helps build an equation using and/or statements. An example of using the Logic Wizard would be if the yield was less than 100 bushels per acre and soil pH was less than 7, then we want the result to be 120 pounds per acre. The constant values area is used to enter numbers into the equation. Simply type the value and click Add to Equation. Now that we have defined the different areas, let's go through an example. We want this equation to be a line prescription based on the soil pH attribute in the soil sampling operation. First, we will go to the Variables and Spatial Functions and add soil pH. Next, we will start entering the equation. For the rates we want to apply, we want to apply 2.5 tons if the soil pH is below 6, 2 tons per acre if the soil pH is 6 and 6.3, 1.5 tons if soil pH is between 6.3 and 6.5, and nothing if the pH is above 6.5. Since these are defined ranges and rates, the easiest way to create this would be using the Range Wizard. In the Create a Range Based on Results window, select the variable that we want to reference, in this case soil pH, and add the number of ranges desired, in our case 4. Starting with the first range, enter the starting value in the If Value is Greater Than column, and the ending value for that range in the And Less Than or Equal To column. Then, enter the value you want to be applied to this range. Continue this for all remaining ranges, and when finished, select OK. We will see that ranges and rates that we set in the Range Wizard have now been formatted to include the math and logic operators. Using the Range Wizard is an excellent way to observe how an equation should be formatted and structured when starting to use the equation-based analysis. After you are finished, verify that the equation is properly formatted by clicking the Validate button. This will ensure that your equation is properly built. If there is an issue, an error message will appear and will highlight the area with the problem so that you can quickly edit it. It is always a good idea to use this tool often when building complex equations, so you can catch any issues as soon as possible. If the equation is valid, click Finish, and you will return to the Analysis Types to Run window. Select the prescription that we just created under the Saved Equation-Based Analysis functions. Then, select whether you want to run the selected analysis for a single or for multiple fields. Choose the grower, farm, and field and other management information to run the equation against in the Select Data Filters window. Then click Next and Finish. The Analysis Editor window will open with the resulting equation map. Click Save at the bottom and use the Filter tool to select how it will be saved to the management tree. After saving, the analysis result will close. Verify that the output is correct by comparing the data used to create the equation to the new layer. Now you know how to set up, create, and run an equation-based analysis in the SMS Advanced software. If you'd like to see more short tutorials from Ag Leader, please subscribe to our YouTube channel.